So we will start. We yesterday learned the methods of preparation from alcohol chapter. So many questions. All of you learned that from alcohol. How do you get chloroalkanes and bromoalkanes and iodoalkanes? All the three we learned from alcohol, and then we learned from alkanes also, isn't it? Now the next topic is electrophilic substitution reactions. See, whenever you see electrophilic substitution reaction, that will happen only with aromatic compounds. Okay, so electrophilic substitution reaction, you remember last year in benzene chapter we learned nitration, halogenation, alkylation, isn't it? Friedel-Crafts alkylation, Friedel-Crafts acylation, these are all electrophilic substitution reactions. So here our topic is how to prepare aryl halides, haloarenes, isn't it? So the electrophilic substitution will be halogenation. You are able to follow? So from aromatic compounds, whenever electrophilic substitution comes, it majorly happens in aromatic compounds. So aromatic compounds, the halogenation. Halogenation is done with the halogen in presence of a halogen carrier like iron or iron chloride, Fe or FeCl3. Last year you learned also a little bit about that, isn't it? So that we will see I will just check. Oh, okay. So I will go to the board. Board is visible? Clear? So can you see the board?
Yes, ma'am.
So halogenation, so we will take suppose I take a benzene. Benzene, if I want chlorination, I will take a chlorine in presence of Fe, iron. Then I will get chlorobenzene. This is it. So you should remember about the halogen carrier. It can be iron or iron chloride. And the bromination, you will take benzene. If it is benzene, take instead of chlorine, bromine. Iron should be there. You will get bromobenzene. Okay. So this is and for these two you understood. And for iodination, you require.
Ma'am, these are what reactions?
These are electrophilics. Next topic, electrophilic substitution reaction, where you will get the aromatic halogen compounds. So that is haloarenes, ARENES. Haloarenes are aromatic halogen compounds. Okay, this much understood? Any doubt?
No.
Okay, so in the book, textbook, they have given toluene. If you see the book, so here if chlorination happens, then iron. So last year we learned, so the methyl group is ortho-para-directing, so you will get a mixture of orthochlorotoluene and para-chlorotoluene, isn't it? So that is, if bromination means instead of chlorine, you will take a bromine. This is electrophilic substitution reaction. But iodohalane I did not say. Suppose I want iodination. I want an iodohalane. Suppose I want, toluene on iodination. I will put the catalyst and I have to put an oxidizing agent like nitric acid. Then I will get I plus I. And from benzene, if I do iodine, iron, nitric acid. Nitric acid is also required. Then I will get iodobenzene. Understood? Why this is happening? In the case of this is happening because the byproduct is HI. In this case, the byproduct is Hi, hydrogen iodide, which is a reducing agent. So once it is formed, it will convert, and this reaction is reversible. It will convert the iodobenzene to benzene. That is the reason. This is a give reason question.
Ma'am, can you explain the second step again?
Second one is I took benzene instead of toluene. So for getting iodobenzene, I have to put iodine and a catalyst and nitric acid. That is the point, okay? So this reaction is iodination alone is reversible, and you have to add a catalyst and also nitric acid. That is what this nitric acid is required. Why we are adding nitric acid only in the case of iodination? Because when you do the iodination, the byproduct is Hi. The byproduct is a reducing agent. It reduces the iodobenzene back to benzene. Clear?
Yes, ma'am.
So I will write that question. I will give the answer.
Ma'am, show the board for a minute, please.
Done?
Yes, ma'am.
So the question is, you write in electrophilic substitution reaction with the iodine. Electrophilic substitution reaction with iodine is carried out in presence of nitric acid. Why? Electrophilic substitution reactions of iodine, nitric acid is required. Why? That is the question. You understood the question?
Yes, ma'am.
Yes, ma'am.
The answer you write. Okay. When iodination takes place, hydrogen iodide is formed as a byproduct. When iodination takes place, hydrogen iodide is formed as a byproduct. Which converts the aryl iodide, to the aromatic hydrocarbon. Which converts aryl iodide to aromatic hydrocarbon. The second important point I forgot to tell, you say that the electrophilic substitution reaction with the iodine is reversible. 2 points. Okay, electrophilic substitution reaction with iodine is reversible.
Ma'am, can you repeat the first point?
First point, you wrote the first sentence, when the electrophilic substitution reaction is carried out with the iodine, Hi is formed as a byproduct, that you wrote.
Yes, ma'am.
The Hi will convert the aryl iodide to aromatic hydrocarbon. Hi will convert aryl iodide to aromatic hydrocarbon. Now got?
Yes, ma'am. And the second point also.
Second point I said, the electrophilic substitution reaction with iodine is reversible. That is why it is converting back. Okay?
Okay, ma'am.
So, have you all written?
Yes, ma'am.
So, we will go to the next reaction. This is a very important reaction. This reaction will come in amines also. Organic nitrogen compounds, there is a chapter in that also it will come. Sand-Mayer reaction. So this is again for getting aromatic haloarenes or aromatic halogen compounds. Okay. And for this, you have to take the starting material is aniline. On the benzene ring, NH2, this is aniline. And you have to convert aniline to a compound called benzene diazonium chloride. Okay, for that, you will take Na, Na2 and HCl and ice cold. You will do this in the lab also. Ice cold temperature. And you will get this compound, which is a very important compound. N2 plus Cl minus. This is called benzene diazonium chloride. You will, one topic itself is there in organic nitrogen compounds. You will learn in detail. For time being, you will understand this much. Aniline with NaNO2 and HCl and 273 to 278 Kelvin. You will get a benzene diazonium chloride. This much is clear? Write this much. This is a new compound. Anyway, you will come to see this compound very often later. Benzene diazonium chloride. Any doubt?
No, ma'am.
So have you written? Then our aim is not this. We want haloarenes, chloro, benzene. Say. What is the doubt?
Ma'am, what is the valency of X in that diazonium?
See, there is a triple bond between nitrogen and nitrogen. That structure and all you will learn in detail in the organic nitrogen compound. Now for time being, you will say N2 plus Cl minus. Okay?
Okay, ma'am.
That is why plus is coming. There is this nitrogen, there is a triple bond between C this way. That you will learn later. Okay? So this is benzene diazonium chloride and this is the starting material. We have to take this compound and I'll rub it off. This much have you written?
Yes, ma'am.
So this benzene diazonium chloride. If you want chlorobenzene, you will take cuprous chloride and HCl. That HCl is not given in the book in this, but HCl is there. You will get chlorobenzene and nitrogen. If you want bromobenzene, you will take cuprous bromide and HBr. You will get bromobenzene. If you want iodobenzene, you will take potassium iodide. You will get iodobenzene. It is a very important
Ma'am,
reaction.
in bromine and this iodide, what happens to Cl, ma'am?
That
What
will
happens
be,
to Cl?
that will be there. That will come out. The byproducts will be there. One byproduct only they have shown.
Okay.
Okay.
Fine.
So these are the three aryl halides. You can get chlorobenzene, you can get bromobenzene. Chlorobenzene and bromobenzene are similar. Iodobenzene, this will not work. You have to put potassium iodide. Understood? Any doubt you can ask? Okay, children?
Yes, ma'am.
Anybody having any doubt, you can ask now. Okay, so that is from electrophilic substitution reaction. Now we will see. So we have learned from alcohol, we have learned from alkane, electrophilic substitution reaction. Fourth one is from alkenes. So from alkenes, I will take an alkene. And if I want bromination, I have to take a hydrogen halide. This you learned in 11th. Hydrogen halide, H will come to one carbon and a double bond will become single bond and a Br will come to the other carbon. This you learned, isn't it? You remember Markovnikov's rule. This is a symmetrical alkene. If the alkene is unsymmetrical, then the addition takes place according to Markovnikov's rule. How many of you remember Markovnikov's rule?
Yes, ma'am.
What is it? Markovnikov's rule?
Ma'am, in the reaction,
Hydrogen.
hydrogen with the lower number of carbon, the carbon
The
atom with the lower
negative
number,
part
hydrogen will get the free electron.
Halogen will go to the carbon containing less number of hydrogen.
Good, Isha.
Yeah, that's what.
And Amita. So many are saying, good, I am happy, you remember. So in the case of addition, this is the additive, HBr. The negative part and the positive part will be there. Negative part will go to the carbon containing less number of hydrogen. So those who do not remember, you can write. So the negative part, CHBr. Negative came here, positive is coming to this. So it becomes CH3. So whenever addition takes place, the double bond becomes single bond. Now, remember it? So that is it. So, and then you also learned that if this reaction takes place in presence of peroxide, opposite will happen, isn't it? Anti-Markovnikov's rule. Clear, children?
Yes, ma'am.
So this you write, one we will write with peroxide and then we will go to the next.
Which reaction is this?
This is reaction of an alkene with the hydrogen halide and the addition reactions of alkene with the hydrogen halide, and the reaction takes place according to Markovnikov's rule. You forgot, Anand?
I remember Markovnikov's rule, ma'am. I just asked, like, is it there in the book?
This 12th book. 11th
Yes, ma'am.
you learned. 11th you learned.
That I remember, ma'am.
So that is what. So Markovnikov's rule, you know that negative part of the addendum will come to the carbon containing less number of hydrogen. So negative part is Br, it is coming here. Positive part is hydrogen, that is coming here. Now clear?
Okay. Yes, ma'am.
We will do that, the same compound, see this. I'll write again propene. If the reaction takes place in presence of peroxide, then opposite will come. So Br will come here, H will come here, and you will get CH3, CH2, CH2, Br. This we already learned in 11th. Is it okay?
Yes, ma'am.
So we'll move to the next reaction. So the next reaction is, suppose you must have, I already told you last year, test for unsaturation. Anybody remembers test for unsaturation?
Bromide water test.
Bromine water test, KMnO4 test, isn't it? So out of that bromine water test. So here, in the case of alkenes, if you take, if you add bromine in CCl4, then you will get a dihalide, and the color of bromine water is reddish in color, and that color will be discharged. So it is a test for unsaturation. Unsaturation, here double bond is there. So that is the next reaction. Bromine in carbon tetrachloride. You will get dibromoethane. So dihalide you will get when you treat it with the bromine in carbon tetrachloride. Okay. So that is why we say bromine water test is a test for unsaturation. So this is what is happening. Bromine water is reddish yellow in color, and that color is discharged due to the formation of this compound. Okay. Okay, you can ask any doubt on this. If you have any doubt, you can ask.
And the reddish color of the bromine water is discharged in the product?
No, you see, when you add, suddenly the bromine water's red color will disappear. It becomes colorless. That is what disappear. That is why we say discharged.
Okay.
Color will not be there.
Ma'am, this red color is due to which compound, ma'am?
Bromine water. When you add this, red means it is yellowish red. That bromine water when you add, if no reaction takes place, that color will be there in the solution. But that color will disappear. Similarly, KMnO4, you will understand better. Potassium permanganate, you must have seen violet in color, purple in color. So if you add potassium permanganate solution to an unsaturated compound, the color disappears. The solution becomes colorless. That is why we call it as a test. So this is bromine water test. Unsaturated compounds decolorize. If you can say discharge if you don't want to decolorize. The color decolorize bromine water. Understood? And that decolorization is due to the formation of this compound. Clear now?
Ma'am, even permanganate test is used for unsaturation, right?
Yes. Permanganate
Okay.
is there. Okay, here our topic is this, not a test for this. Here our topic is preparation of haloarenes or haloalkanes. So that is why this is written. Okay.
Okay, ma'am.
So we'll go to the next reaction. Next two are main reactions, so very, very important. The next one is Finkelstein reaction. Finkelstein reaction. So you will get iodo alkane. You will get iodoalkane from chloroalkane or bromoalkane. You can use any. So Rx I will write, and I will write X can be chlorine or bromine. Okay. So you take the reagents sodium iodide in presence of acetone. You will get Ri plus NaX. Very simple reaction. This is Finkelstein reaction. So here Rx can be RCl or RBr. So from chlorides or bromides, when you add NaI and acetone, you will get iodide. Clear? Main reaction, so you have to learn. Any doubts? Have you understood? This you have to. This is a name reaction. Like a words reaction, so many name reaction you learned by heart. You have to learn. And but you have to, if you are writing RX, you have to say X can be chloride or chlorine or bromine. Okay?
And what is I here? Iodine.
The topic itself is haloalkane. Halogen can be chlorine, bromine or iodine. So here you will get iodoalkene by Finkelstein reaction. Okay?
Yes, ma'am.
Now for fluorine we forgot, isn't it? One method of preparation for fluoroalkane. So that is
Ma'am, Prashant has a doubt.
huh? What?
Prashant has a doubt, ma'am.
Prashant, once more there is a network issue. Oh. So Finkelstein reaction, you can take an alkyl chloride or an alkyl bromide. So in general, I will say RX. And X is chlorine or bromine. So the reaction is with NaI. In presence of acetone, you will get iodoalkene plus NaX. Okay, Prashant? Okay, so this is Finkelstein reaction is you have to, when you learn, you have to learn like that. Finkelstein reaction is used for making iodoalkane. And the next reaction, Schwarz reaction is used for preparing fluoroalkane. So here, that is the Schwarz reaction is still easy. You just have to, here you have to remember two reagents, NaI and acetone. They are only silver fluoride. You can use other fluoride also, but learn only with one fluoride. That is easy for you to remember. So the same thing, Rx. X can be chlorine or bromine. From Rx only you are getting this fluoroalkane. So X can be chlorine or bromine. When you treat with the silver fluoride, you will get a fluoroalkane. So this Finkelstein and Schwarz reaction, they are halogen exchange reactions, isn't it? Only halogen is exchanged. You will take alkyl chloride or alkyl bromide, that chlorine or bromine is exchanged by iodine, isn't it? So second Schwarz reaction also, you will take an alkyl chloride or alkyl bromide, that chlorine or bromine is replaced by fluorine. So both are halogen exchange reactions. So Schwarz reaction we will see. So you will take Rx. X can be bromine or chlorine plus silver fluoride. You will get Rf plus AgX. That is it. Okay. Ask any doubt. We will do the index questions now. Fine, children? Any doubt? Abhishek, Jay and all, are you able to follow?
Yes, ma'am.
Pankaj is here. Pankaj? Pankaj, are you here? Pankaj? So here, Prashant, you are asking Schwarz reaction is for what? For getting fluoroalkane. For getting fluoroalkane, you see the board. You will get RF. RF is alkyl fluoride or fluoroalkane. So from alkyl chloride or bromide, you will get alkyl fluoride. In other words, alkyl fluoride or fluoroalkanes. Now clear, Prashant? Okay, so 2 days we have, 1.5 days we have taken for this reactions itself for method of preparation. So we will just recapitulate. So first reaction was with the reaction with alcohol, reaction from alcohol. And so I divided into 3 and told you to learn like that: alkyl chloride, alkyl bromide, and alkyl iodide. And if the different reagents we learned, PCl5, thionyl chloride, PCl3, isn't it? And then HCl in presence of zinc chloride, that reaction we learned. Then we said that for bromoalkane, NaBr and sulfuric acid. For iodoalkane, we don't take NaI and sulfuric acid, we take phosphoric acid. And then another method for getting bromo and iodoalkanes are from red phosphorus and bromine or iodine. Like that, you have to remember, recollect in between. Then you will remember the reactions. So that we learned, and then we learned from alkanes, and today we learned electrophilic substitution reaction. So from hydrocarbon you can get, but you have to use a halogen carrier like iron. And in the case of arenes only, you have to use nitric acid. That we learned. Then we learned another important reaction, Sandmeyer reaction. And then after that we learned from alkenes. From alkenes by adding hydrogen halide, but then you should follow Markovnikov's rule. If peroxide is added, we will follow anti-Markovnikov's rule, isn't it? And please repeatedly you learn, and then like this you recollect in between. Then we learned the reaction bromination. Bromination in presence of CCl4, you will get dibromoalkane. Then halogen exchange reactions, 2 reactions, Finkelstein reaction and Schwarz reaction. You can go through fast, 2 minutes I will give. And you want that or you are clear with it, just take 1 or 2 minutes to remember, recollect. Like I said, these are the reactions. Now we will do the index questions based on the reactions. I will give you 1 minute, 1 or 2 minutes. You go through that, okay? But practice for 1 minute so that this questions you can answer. So when you finish, you tell. Just to go through that and recollect. Like I said, these reactions, these many topics. Under these reactions. Now we will do the question answers. Okay, done, children? So we will do this question. Reaction with HBr. So here, this is a carbon, isn't it? This is a carbon. And so out of this addition will take place across the double bond. And which carbon is having less number of hydrogen? This one. Here, 1, 2, 3, 4. No, there is only one hydrogen. Here there are two hydrogens. So Br will come here, isn't it? So the product is double bond becomes single bond. This C you don't write because they also did not write. If they don't write, I just make you understand I wrote that C. So you don't write a C. Okay? So it is like this double bond. Have you understood? Is it okay?
Ma'am, can you explain once more?
This is addition of HBr, and addition will take place here across the double. Here only, between these two carbon only addition will take place. You have to count the number of hydrogen atoms of each carbon. In this case of this is a carbon, there is a carbon there. In this case, there is only one hydrogen. In this case, there are two hydrogens. So Br will come here. So I just put Br here. The changes, double bond will become single bond, and that is remaining as such. Clear now?
Yes, sir.
Okay. Can I go to the next question? Prashant, have you understood? Prashant, any doubt? Where three hydrogen?
Ma'am, can you show the board once again?
Where three hydrogen atoms? Here three, one more will come. Yes, you are right. HBr. H is added, no? Yes, you are right. H is added here. Right, Vishnu Priya. We added Br only. H I forgot to put. H is here. Now okay? Okay, Amitav?
Yes, ma'am. Done.
Bharati is present? Is Bharati there? Bharati?
Yes, ma'am.
Why reluctantly saying you were not there?
No, ma'am, I was there.
Okay. So next question. Next question. This one. Peroxide. So anti-Markovnikov rule will come. So these are the two carbon. Anti-Markovnikov H will come here and Br will come here, isn't it? So CH2, CH2, Br. So we added H and Br. Because peroxide is there, anti-Markovnikov rule. Okay. So we will go to index question 10.5. 10, this I am rubbing. 10.5.
Ma'am, did you do the second question?
Second we did yesterday, na? 10.5 you are saying?
4, ma'am.
10.4. 10.4 we did, na? Yesterday we did. 10.5, out of that, 1 we did yesterday, 2 we did, 3.
Ma'am, I think she means example 10.4, the second part.
Example 10.4. Second part. Okay, second part. Okay, that is there. CH3, CH2, CH double bond, CH2 plus HCl. So Markovnikov. Cl will come here, H will come there. So CH3, CH2, CH, Cl. No peroxide, so Markovnikovs. Isn't it? Is that okay? Naomi?
Yeah.
Okay. So now we will go to index question 10.5. So 10.5, fourth one. This type of questions are repeated questions in board. So here, the first thing you should understand, the addition will take place across the double bond. So this carbon, there is a carbon here, there is a carbon here. So across this only addition will take place. Now you have to count the number of hydrogen in each carbon. This carbon, 1 here, 1, 2, 3, 4, no hydrogen. This carbon, 1, 2, 3, 4, there is one hydrogen. Isn't it? So, which is having less number of hydrogen here. So, you don't have to write all that. Even the carbon also you don't have to write. You will write that iodine will come here. So, the product is here. Double bond will go, it is addition reaction. There is a CH3 here. Here, iodine will come. And H will come here, it is understood. You don't have to write the H. Clear?
Ma'am, please explain once again.
See, this is addition of HI. The previous questions, it was that was long chain, straight chain compound. Here it is an aromatic compound. Addition of HI. So H and I will go across these two carbon. H will go to one carbon and I will go to another carbon. Now there is no peroxide. It will happen according to Markovnikov's rule. So you have to count the number of hydrogen atoms in each carbon. This is the compound. Isn't it? So these are the two carbon, one carbon here, one carbon here. So how many hydrogen atoms in this carbon? You have to count the valency. 1, 2, 3, 4, no hydrogen. In this carbon, 1, 2, 3, one hydrogen is there. So I will come here. So I put it here, I. And so addition reaction double bond will go. So I didn't put any double bond here. H will come here. And that anyway in this we don't show carbon and hydrogen. Now clear?
Yes, ma'am.
Anybody else? Jay, Abhishek and all understood? Arbas?
Yes,
All
ma'am.
of you understood?
Ma'am, my call was disconnected. Could you explain again?
This question, okay. So this is the question, and here this is a this is an aromatic hydrocarbon. Here addition of HI, and there is where addition of HI takes place across the hydrogen and iodine will go to only these two carbon. Across the double bond only addition will take place. So you have to see where there is no peroxide. So Markovnikov's rule, I will come to the carbon containing less number of hydrogen. So you count this carbon, you will count 1, 2, 3, 4, no hydrogen. In this carbon, 1, 2, 3, one hydrogen is there. So, but hydrogen atoms we are not writing anywhere, but you have to count. So this carbon is having less number of hydrogen. So I will come here and H will come here, and we don't put to the double bond. This is the product. Understood, Ruchi?
Yes, ma'am.
Anybody else? Prashant, is it clear? Okay. So next question. We'll go to the next question. Next is easy. It is our Schwarz reaction. So sorry, Finkelstein reaction, isn't it? So you will get iodine, ethane. Even though acetone is not there, they should have put acetone, but if it is not there, you put it like this. It is Finkelstein reaction. Okay. Now the next one, sixth one.
Ma'am, will the sixth answer be dibromo, no, ortho dibromo hexane?
Say the question again, Anand.
Will it be ortho dibromo cyclohexane?
The name of the compound you are asking?
No, like the final product.
No, the previous compound.
No, this sixth one.
Sixth, I am saying, I am doing. Okay. It is not that, Anand. Heat and light is from heat and light. It is not with carbon tetrachloride. It is with heat and light. Only one monobromination only will take place. Okay. And here, this is not in the syllabus, the reaction, but it is asked in the exercise. You just understand that when this happens, then allylic bromination takes place. Allylic bromination. Bromine will come here. So this is the product. Allylic bromination. You write it there down. Allylic bromination will take place. Okay. This is the product.
No, hydrogen will be released, right?
Ah, yes. That is HBr. Byproduct will be HBr. So down you have to remember like that, children. In this case, you write hint. Allylic bromination takes place. Allylic, I taught you the very first day. Here only. This is the carbon containing double bond. Next. Okay, children. Okay. So we have to see the examples, exercise in text. These are the questions. Okay, so practice it, and if you do not understand, the next day also after the class you can ask. When other children will not waste their time, then you can ask. Okay, so now we will go to the sub question 6. What Vishnupriya? What is the doubt in 6? What is the doubt, Vishnupriya? In text 10.5.
She was asking which question, so I was just telling her.
Sixth question, last question. It was who was asking sixth question?
Naomi.
Naomi, you understood, no? Now? Okay. So that is from methods of preparation. Now you have understood how many types of questions, how many. It's not that they will not ask you how do you prepare haloalkane or chloroethane from alcohol. No, not that way. And here conversion questions are also there. So everything will be indirect questions. So whatever questions in the in-text and exercise you have to practice. Okay, and give reason questions also. In this methods of preparation, I have given you 2 or 3 give reason questions also. So that is how. So daily you practice, it will be easy. So now we will take the physical properties. Okay, so physical properties of haloalkanes, the 2 important physical properties are boiling point and solubility. So there also questions are there. So boiling point, see if you have different chloroalkane, bromoalkane, iodoalkane. If you have RCl, RBr and RI. which will have higher boiling point. How do you understand about the boiling point? If the, see here, these haloalkanes are polar molecules, okay? So the force of attraction between them, they are the van der Waals equation. Even though they are polar compounds, there will be attraction between the molecules, isn't it? And so the attraction is more, means boiling point will be more. And so there will be van der Waals force also. Van der Waals force will be more if the compound molar mass is more. So the first question, if I take RCl, RBr and Ri, they will ask you to arrange according to the increase in the boiling point. So for example, CH3Cl, CH3Br, CH3I. So you know that iodine is having higher atomic mass. So Ri will be having higher boiling point than RBr, then RCl. Understood? And where R will be the same. If it is, arrange the following: CH3Cl, CH3Br, CH3I. Then who will be having the least? CH3Cl, then CH3Br, then CH3I. Have you understood? So the iodoalkanes will have higher boiling point because van der Waals force will be more. Why more? Because iodine is having higher atomic mass. Is it clear?
Yes, ma'am.
Now, second point in this, branch.
Ma'am, they have their van der Waals force is weak.
More. Atomic mass more
Okay.
means more. Okay.
Yeah.
Chain is more, chain length is more means more van der Waals force. So if more van der Waals force, more boiling point. Okay. So butane will have higher boiling point than propane because chain length is more. Okay. Next point is branching. If the compound is a branched compound, that will have less boiling point. If branching is there, boiling point will be less. Okay. So they have given example. See, you see the example. See 1, 2, 3, 4. Bromobutane, 2-bromobutane, and tertiary butyl bromide. So the boiling point is decreasing when branching. Then straight chain is having 375. When there is one branch, 364. And branching increased, the boiling point is decreasing. So the point you note down, if branching increases, boiling point decreases. Clear? Is it okay?
Ma'am, can you explain that example once more?
Example, you see that the first compound, there is no branching. CH3, CH2, CH2, CH2Br. Have you seen that example?
Yes, ma'am.
There is no branching. Boiling point is 375. In the
Okay, ma'am.
second case, branching is there. So it is decreasing. That Br is not in the straight chain. It is down. So it decreases. In the third compound, branching is more. So the boiling point decreases.
Yes, ma'am.
Understood, Priyanka?
Yes, sir.
So now there is a board question there in the last paragraph, small paragraph. Para isomers. So suppose you take aromatic halogen compounds or haloarenes. And so when you take dihalates, there will be ortho, meta and para dihalates. Out of that, para will be having the highest melting point or boiling point. That is the question. Why? Because in the case of para, because of the symmetry, the more closely packed they will be arranged in the crystal lattice. So you underline this. The para isomers are high melting compared to ortho and para meta isomers because it is due to symmetry of the para isomer that fit into the crystal lattice better as compared to ortho and meta. Underline that. That is a board question. Why para?
Ma'am, what is crystal lattice?
That is, see, the compound means there will be so many, you will be learning. Another thing, children, the deleted topics are coming back this year for you, okay? So solid state chapter is there. So there you will learn. Crystal, if I have a crystal of that substance, that will have a large number of unit cells arranged. You will learn in solid state. And that the total, after arranging a large number of small units arranged in 3 dimensions, then we get a crystal. That full arrangement is the crystal lattice. Okay. So in the case of para, due to symmetry, that it will fit more into the crystal lattice. So it will be more closely packed, more will be fitted, and so the melting point will be high. So you will be writing that sentence. Is it okay? Understood? Naomi?
Yes, ma'am.
Okay. So that is, and then the next point is solubility. Solubility, I think I have to go to the board. So I'm taking methyl chloride and solubility in water. So this is the solvent. Solvent is water. The point is haloalkanes are not soluble in water. That is the question. Give reason why they are not soluble in water. So to understand that, you know that suppose this when I had water, and so if this is soluble means, see, before that there will be force of attraction between methyl chloride and methyl chloride. There will be force of attraction between water and water. What is the force of attraction? Intermolecular hydrogen bonding. And when we put this into water, then there will be interaction between this and water. So 3 interactions will be there. Already methyl chloride, chloromethane and chloromethane one interaction. Then water and water, intermolecular hydrogen bonding. And when we put, there will be interaction between the chloromethane and water. So the compound is soluble when this interaction takes place, energy will be released. And the energy released when due to the interaction of chloromethane and water, if it is higher than the energy required to break this and this, then the compound will be soluble in water. Have you understood?
Once more, please.
See, if the compound, suppose I am going to dissolve chloromethane in water. So chloromethane will be soluble in water only if the energy released due.
Ma'am, can you explain that once more?
I am explaining. See, here the topic is solubility. Okay. Suppose I take this compound, chloromethane, and the solvent is water. Okay. So there will be 3 types of interaction when I put. The first 2 are already there. Suppose I take one chloromethane, there will be different molecules of chloromethane. There will be interaction between the molecule of chloromethane and chloromethane. That is interaction 1. The second one is solvent-solvent interaction, water and water. There is interaction. There is an intermolecular hydrogen bond. Isn't it? Hydrogen bonding, and more bonds are there. Intermolecular hydrogen bonding is present in water. That is the second interaction. Third interaction is between methyl chloromethane and water. So 3 interactions are there. And so in this first case, if you want this to be dissolved in water, then you have to break these 2 interactions. Energy is required to break these 2. This has to be broken, this has to be broken. Energy is required. How do we get? When you put a substance in water, then due to this solute solvent interaction, some energy will be released. And depending on the substance, the energy released will be more or less. Suppose the energy released is more, then we can break this interaction and this interaction, and the compound will be soluble in water. Understood?
Yes, ma'am.
Others, it is little, see, you have to, I will explain once more. Suppose I am going to dissolve chloromethane in water. Okay, so before that, when I put chloromethane in water, there will be three types of interaction. Chloromethane, among the chloromethane molecule is the first interaction. It is there. Second interaction is among the solvent molecule, and that is a strong interaction, intermolecular hydrogen bonding. And the third one is between this chloromethane and water. So whenever you add a compound to water, if the interaction between the compound and water is more, means more energy is released. So here only energy is released. And that released energy will be used for breaking these interactions, two interactions. If you get sufficient energy released by this interaction, then this interaction and this interaction will be broken and the compound will be soluble in water. Now clear? Prashant? Priyanka?
Understood, ma'am.
So in this case, children, in the case, the point is haloalkanes are sparingly, they are rarely soluble in water. What is the reason? The energy released due to the interaction between the haloalkanes and water is less. It is not sufficient to break the interaction between the haloalkane molecules and the intermolecular hydrogen bonding in water. Now clear? That is the point. This is a give reason question. Is it okay?
Yes, ma'am.
So you can underline. The sentence is given properly in the book. So I will tell you what to underline here. Haloalkanes, the first point. Haloalkanes are very slightly soluble in water. So in order for a haloalkane to dissolve in water, energy is required to overcome the attraction between haloalkane molecule and to break the hydrogen bond in water molecule. So less energy is released when new attractions are set up between haloalkane and water molecule. And so it is, as a result, the solubility is less. That much you have to write. Is it okay? So that is one question. And the second question is given in 10.6 we will do now. So the first question is you give a reason why they are not slightly soluble in water. Clear?
Which question, ma'am?
Next question is 10.6. I will the first question is give reason why are they not soluble in water. Okay, now 10.6 we will do and we will wind up the class. 10.6. Okay, 10.6. Take the question. Arrange the set of compound in the order of increasing boiling point. So the first one is bromomethane. Bromomethane is this. And the second one is bromoform. Bromoform is CHBr3. Chloromethane, CH3Cl. And dichloromethane, CH2Cl2. So you have to arrange in the increasing order of boiling point. So see, bromine is having higher atomic mass than chlorine, isn't it? And here, see, first the increasing means this will be having the highest, isn't it? Then here two chlorine atoms are there. This will be having the second. Then bromine, and this will be the least. Okay, so understood?
Ma'am, can you please repeat?
Yes, I will repeat. So
Ma'am, it's chloromethane and then dibromomethane, ma'am.
Bromomethane is written. It is dibromomethane. Okay, okay. It is not dibromochloride. It is this, isn't it? Okay. So bromine is having higher atomic mass than chlorine. So the highest will be this. Then comes this. Then comes this. So the lowest will be chlorine. So chloromethane is having the lowest. Then comes one bromine. Then comes two bromine. Then the highest is 3 bromine. Clear? Because bromine is having higher atomic mass. Is it okay?
Yes, ma'am.
So, next one. 1 chloropropane. This I will rub it off. This is the order. All of you write. This is the order. Increasing order. Okay? Now the next compound. Next series. 1 chloropropane. So this is CH3, CH2, CH2, Cl. This is 1 chloropropane. Isopropyl. Iso means I told you this group immediately you have to write. Iso means you will write CH3, CH, CH3. And a propyl means 1, 2, 3. So this is the second one. And the third one is 1 chlorobutane. So CH3, CH2, 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 Cl. So which is having highest? This. Chain length is more. And the next will be this. And here branching, this will be having the lowest. Isn't it? So the lowest is isopropyl chloride. Then comes chloropropane. And the highest is chlorobutane. Isn't it? Doubt you can ask? Any doubt? Is it okay, children? Okay, so then I will just wind up. So the
Ma'am, why is isopropyl chloride less than chloropropane?
branching. We said that enough. If branching is there, then
Okay.